Okay, this is the video for those who could not understand anything from the content page. Okay, you must have been going through the content pages in all the lessons, but you might not have understood most of the things there. So for such people, this might help you. So once you finish watching this video, you go through the content pages once again, word by word, look into all the PowerPoints and the GeoGebra files and everything word by word. I think then you'll be able to have a better understanding of the contents. Okay, this is the especially for those who haven't understood anything so far in regarding the complex numbers. Okay. Now, what is a complex number? This I think you must have understood basically what a complex number is. Basically speaking, when you wanted to solve some equations like this, it was not possible. So this actually gives you x is equal to square root of minus 1, right? Instead of just writing square root of minus 1, we just replace the symbol notation as I. That's it. And this I is the complex number. Okay, it's just a notation for square root of minus 1. So therefore what happens is I times I will be I square, so which is root of minus 1 times root of minus 1, which is actually negative 1. Okay, so I square is negative 1, and you have some properties. What about I cube? I cube will be I square times I, which is negative 1 times I, which will give you negative I. So I cube is I square is negative 1, and so on. All these things are there in the contents. Okay, I think this part would be very easy to understand. Just take it as I is square root of minus 1. Okay, and this is a basic complex number, just an I. For example, if you have this equation x square plus x plus 1 equal to 0, fine. If you wanted to solve this using the quadratic formula, then you will get minus 1 plus or minus square root of 1 minus 4 divided by 2, right? Using the quadratic formula minus b plus or minus b square minus 4ac over 2a. So this is actually minus 1 plus or minus square root of negative 3 over 2. Okay, now comes the problem, that is, this is where you are going to use the square root. So when it comes to square root of negative 3, we split it and write it as negative 1 square root of negative 1 times square root of 3. So as we said, square root of negative 1, the notation we are using I root 3. So square root of negative 3 is nothing but I root 3. So this one can be written as minus 1 plus or minus I root 3 over 2. So which I can split it and write it as negative negative half plus I root 3 over 2, or negative half minus I root 3 over 2. Okay, so I have two complex numbers here, right, which is of the form a plus ib, where a is this number and b is this number. Okay, so any complex number in general will be of this form, a plus ib. This a is alone, that is without I. This part is with I. Okay, so without I part is known as real part, and the part where you have the I is known as imaginary, because I is called imaginary number. Okay, so there are two parts in any complex number, which is real and imaginary. Real is the part where you don't have any i's attached to that, and the imaginary part is the one which has the I. So a plus ib is a general complex number form. Okay, now what is a conjugate? This again you must have come through this in your content. See, I said a general complex number is a plus ib. So the conjugate of this is a minus ib. Okay, so these two are conjugate of each other. A plus ib is the conjugate of a minus ib, and a minus ib is the conjugate of a plus ib. Like if I have 3 minus 2i, its conjugate is 3 plus 2i. If I have 5 plus 4i, its conjugate is 5 minus 4i. Okay, if I have minus 3 minus 8i, the conjugate of this is minus 3. Don't change the minus 3. The change comes only for the imaginary part. Understood? Okay, so these are the conjugates of each other. So what is the speciality on multiplying two conjugate numbers? If I multiply, I'm just introducing multiplication here itself. I think you must have understood. Multiplication of two complex numbers is just like multiplying term by term. Okay, just one after the other. So this is a square right? Minus I A B, A B I, and then plus I B A, that is I A B, and then plus minus is minus, I times I is I square, and there is B square. Okay, this one and this one is I square B square. Okay, now this is A square, these two cancels, minus I square B square. And in the previous page I said I square is minus 1, right? I square is minus 1, therefore minus I square would be plus 1. So this is A square plus B square. So can you see that the I is gone here? This is purely a real number. Okay, so when you multiply two conjugate numbers, you get always a real number. That is, if you are multiplying, say for example 3 plus 2i multiplied by its conjugate 3 minus 2i, your answer will be 3 square plus 2 square. You can check this later. Okay, your answer will be 9 plus 4, which is 13. So it's a real number. Any conjugate number on multiplication gives you a real answer. Okay, addition, subtractions, and multiplication. I just told you what a multiplication is. Just multiply them term by term. And addition is and subtraction. If I have a plus ib and c plus id, just add the real parts together and the imaginary parts together. So you'll have real parts is a plus c plus I and I common, I times p plus d. Okay, adding the real parts together and imaginary parts together. The same with subtraction. If it is a subtraction, a minus c, this is one and this is another one. Okay, a minus c and plus I times b minus d. Okay, so this is addition and subtraction. Multiplication, I just told you how to multiply just here. Now, what about division? I hope you remember something known as rationalizing the denominator. For example, if you have 3 over root 2, what do you do to rationalize the denominator? You multiply by root 2 and divide by root 2 so that the denominator becomes a rational number. Am I right? I hope you remember this. This is exactly what we are going to do here. See, if you have, say for example, 3 plus 2i divided by 5 plus 4i. Okay, now I can't divide a complex number by a complex number. The only thing I can do is I can make the complex number into a real number. Okay, again we just saw that multiplication of two conjugate complex numbers lead to real answer, right? So if I multiply this by its conjugate, I will get the answer as 5 square plus 4 square. Therefore, I can get rid of the complex number in the denominator. Fine. So when I multiply this, I need to multiply the same thing to the numerator. So now it is this normal multiplication, and you can proceed as it is. 3 times 5 is 15 and minus 12i, and 2i times 5 is 10i, and 2i minus 4i is minus I square, 8i square, which becomes plus 8. So this is 15 plus 8 is 23 minus 2i divided by 25 plus 8 is 33. Okay, so this is the complex number you are getting by dividing 3 plus 2i over 5 plus 4, right? We are using the property of conjugate products. Okay. Okay, now let's talk about what is the geometrical representation of a complex number. Okay, so you know a real number can be put on a real line, right? 0, 1, 2, minus 1, minus 2, etc. And any number, any real number, 0.5 or even square roots. You can even mark the square root 2, square root 3 here. I think you know how to mark them. So any real number can be put on a number line, real number line. Okay, so a complex number is like something like this, 3 plus 4i. How do you represent this geometrically? Now we go into the normal xy axis, something like this. Okay, but we name this as Argand diagram. This is basically your two-dimensional graph representation. So 3 plus 4i, take the real part on the x-axis and take the imaginary part on the y-axis. So the real part is 3 and the imaginary part is 4. So the point 3, 4 represents this complex number 3 plus 4i. Clear? Okay. Now this is what is represented by the complex number 3 plus 4i, that is this point 3 comma 4. If I have minus 2 plus 3i, then your number is, your point here is minus 2 and it is 3, therefore minus 2 comma 3, and this is your complex number, and we just make a line which joins the origin like we do it in vectors. Okay, this is the geometrical representation, and the diagram we are doing is known as Argand diagram. Okay, next is polar form. This might be a little complicated for you, but it's not very difficult once you understand it. Okay, when you have a complex number, say I said let's use the 3 plus 4i. Okay, remember your trigonometry with unit circles. Okay, when you had a unit circle, sorry for the diagram, any point on this was cos theta comma sin theta. Remember this? Any point was cos theta comma sin theta. So the theta is the angle made by this point which is joined to the origin, and the angle made by that line with the x-axis, this is theta. Okay, and if this was not a unit circle but it had a radius of r, then your values for x and y will be r cos theta or sin theta. Fine. Okay, now I said this is 3 plus 4i. So can I write this as something like r cos theta plus r sin theta I, right? Because my x value is 3 comma 4. Say for example x, if I have x plus iy, x is r cos theta and y is r sin theta. I just represent x in terms of r cos theta and y in terms of r sin theta. So any complex number can always be represented as r cos theta plus I sin theta, I sin theta r. So what we do is we take the r common, r cos theta plus I sin theta. This is the polar form of a complex number. Okay, and this is simplified and written as r cis theta, that is cos I sin theta. Okay, this is another representation of a complex number. So how do you exactly find it? 3 plus 4i, how do you represent? What is the r and what is the theta? See, if I have 3 comma 4, then it is very obvious that this is 3 and this is 4. So what is r? Using Pythagoras theorem, root of 3 square plus 4 square. Very, very common, right? Which is root 13. This is my r here. Now what about theta? Theta is nothing but tan inverse of this over this. So theta is tan inverse of, this is 4 and this is 3, therefore 4 over 3. Whatever it is, you can find the angle using your calculator. This is how we find the r and theta for this representation for polar forms. Hope this is clear. For more clarity, please go through the content pages and go through the PowerPoints which is given there. You might understand it better, and if you still have doubt, please contact me. And product and quotient when it is in polar form. Say if I have a plus ib, or in polar form, sorry, or cis theta is in polar form. So there are two complex number. One is r1 cis theta 1 and the other one is r2 cis theta 2. Again, this is very clearly given in the content page. For proof, please see the content. I am just giving you what it means by products. That is r1 cis theta 1 times r2 cis theta 2 is nothing but r1 r2 cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2, which is in simplified form written as cis theta 1 plus theta 2. So when you are dividing two complex numbers in polar form, then we have r1 over r2 cos theta 1 or cis theta 1 minus theta 2. This is what you need to remember. Okay, and the proof is given very clearly in the content pages there. Please let me know if you have not understood it. Okay, and solving complex equation, I just solved this x square plus x plus 1, right? That's how you do it. So you did this and we got x is equal to minus 1 plus or minus I root 3 over 2. So the answers were 1 over 2 plus or minus I root 3 over 2. Okay, now let's find what is r. R here is square root of half square plus root 3 over 2 the whole square, x square plus y square, which is root of 1, which is 1. So the r here is 1. Okay, 4, you can check this out. Now what will be your theta? Theta will be tan inverse of y over x, okay, which is tan inverse of root 3, which is negative root 3. So just take it as root 3, which is pi over 3, that is 60 degrees. Okay, so what happens here is it's not just 60 degrees. What happens here, this is x is negative, I'm just considering plus, okay, y is positive, so that means it is somewhere in this quadrant, right? This is 60, but the angle is always taken from the positive x-axis, therefore this is 120. So I cannot give the answer as negative 60 because it's in the negative 60 is somewhere here, right? This is negative 60, which is wrong, right? The answer is not negative 60. The point is here because x is negative and y is positive. The point is in the second quadrant. Therefore, the answer is 180 minus 60, which is 120. So you need to think a little bit before giving the final answer. You have to think about what is the x value and what is the y value and what are the signs of x and y. For example, if you have 1 over 2 minus 1 over root 3, sorry, root 3 over 2, I'll use the same thing. Negative 1 over 2 minus root 3 over 2, I root 3 over 2, the other one, okay. This way you are having both negative, which means this is in this quadrant, right? So this is 180 plus 60. So the answer is 180 plus 60, which is 240. But we don't give the answers above 240. We can give it as negative 120 degrees. I'm so, yeah, negative 120. Yeah, you're right. Okay. So we don't give the answers more than 180 degrees. So the answers always lie between 180 and this is theta and 180 degree, positive 180 and negative. That means either you go from here to here or you go from here to here. Do you understand? So it doesn't exceed 180 degrees in that. Okay, so that's for solving complex number. I think De Moivre's theorem would have been a little bit difficult for you to understand. I'm not sure, but let me just explain. If I have x plus iy and if I can express this as r cos theta plus I sin theta, and then if I want to take it to the power of n, then this value is r power n cos n theta plus I sin n theta. It becomes multiplication of the angles. Okay, this is a continuation of product what we did. You can prove it easily with your mathematical induction. Please check it in the content page. Say for example, if you have 3 plus, again, no, we'll use the same thing as we did before. Minus 1 over 2 plus I root 3 over 2. We had this, and the r was 1 and the theta was 120 degrees. 120 degrees plus I sin 120 degrees to the power of, say for example, 5. So I wanted to raise it to 5. Then my answer will be 1 to the power of 5, which is 1, and cos 5 times 120 plus I sin 5 times 120. This will be my final answer. Okay, and this is it. This is what is there in the lesson this week. This is very preliminary things that I have explained. Please go through the contents again, word by word. Again I repeat, word by word in the content, and watch all the PowerPoints, GeoGebra files and everything. Just don't miss anything. Just go on and see if you can understand that. Okay, all the best.